Hey there, this is Mr. Lamb, and this is the 4.1 guided notes over the Pythagorean Theorem. I know some of you really like these guided notes, so what I'm going to try to do is still make them available for you, and that way as we go forward, you can still be doing guided notes, and you can just do them via video as opposed to live and in person. There will come several times throughout these videos where I may suggest to pause the video and then give yourself some time to try the problem, and then you can just play the video again as opposed to me sitting and waiting. So, starting out with the Pythagorean theorem, the first thing that you need to know is what is the Pythagorean theorem. And the Pythagorean theorem is a squared plus b squared equals c squared. And that means you need to know what is a, b, and c. So let me put in a picture here of a right triangle for you. Here's a right triangle. And this right triangle has some parts to it. The legs are the two pieces right here that make up the right angle. They're both called legs. And you can name those legs in either order, A and B. The hypotenuse, however, is the length of the longest side. It's always across from the right angle, and this is always C. So when I do the Pythagorean theorem, I need to do the legs squared added together and set it equal to the hypotenuse squared. No matter how that triangle gets turned or twisted, it's always the two legs, the pieces that make up the right angle, squared and added. And it is always going to be set equal to the hypotenuse squared. So let's jump right down and take a look at example number 1. What I'm going to try to do is I'm going to try to use the colors red and green, and I'm going to line the legs in red. So here in question number 1, the right angle is right there. So those are the legs, and the hypotenuse will be in green right there. And the Pythagorean theorem says that we want to do the legs squared, so 6 squared plus 3 squared, and it'll be set equal to the hypotenuse squared, so c squared. Well, if you remember what squaring means, multiplying by itself. So 6 squared is really 6 times 6, which is 36. And 3 squared is 3 times 3, which is 9. And that's going to be equal to c squared. 36 plus 9 is 45. So that's going to equal c squared. And then to find c, if I want to know what c is equal to, I need to do the square root of 45. Square root of 45. That is algebraically how you solve when something is squared. You have to put in a square root. And in this case, it says leave your answer in simplest radical form. So radical 45 does simplify. If you remember back to Algebra 1, you can think of a perfect square and what a perfect square could come out of that. And 45 is 9 times 5. So 9 times 5. We'll leave the 5 in, and the square root of 9 is 3. So 3 radical 5 is your answer for C. If you are going to struggle, and if you have questions about simplifying radicals, please, when you get to class, ask me about that, and I can show you a couple of little tricks on simplifying a radical. Otherwise, just get them into the closest decimal. So this is a good time to pause this video and try question number 2 on your own. Here you go, taking a look at question number 2. The legs, again, make up the right angle. And the hypotenuse is what we're trying to find. So we'll call that C. So if I do my legs squared, so 4 squared plus 8 squared has to equal C squared. 4 squared is 16, and 8 squared is 64. that's going to equal c squared. 64 and 16, that is 80. And c squared. And then c is the square root of 80. And the square root of 80, that will simplify. Let's see, 4 goes into it. 4 is a perfect square, so that's 2. And if I divide that by 4, it's 20. Nope, so there's a bigger one. Alright, so what is 80? 8 times 10. 2, 2, 2. That's 2 and 5. So this is 4 radical 5. Again, that little thing up there, that's just how I simplify radicals quickly. And if you want to see that, please just ask me. I would love to share it with you. All right, as we take a look at the last two examples from this set of guided notes, it wants us to find the missing side of the right triangle. And now we're going to round to the nearest tenth. I like this one a little bit better. So number 3, again, I'm going to identify my legs first. So there's my right angle. Those are my 2 legs, 3.9, and I'll call that B. The hypotenuse is 11. All right. Back here. So a squared plus b squared equals c squared. So 3.9 squared plus b squared equals 11 squared. So if I want to solve for b squared, I have to minus 3.9 squared. So b squared is 11 squared minus 3.9 squared. Well, what is that? Well, I'm going to have to go to my calculator. 11 squared minus 3.9 squared. So 11 squared minus 3.9 squared. That is 105.79. 105.79. And then to find b, I will do the square root of that 105.79. And it's going to give me a decimal approximation of square root that answer. I get about 10.3. About 10.3. Now, a good way to kind of check just to see how you're doing on that, the hypotenuse always needs to be the longest side. So the hypotenuse here is 11. And my 2 legs are 3.9 and 10.3, which both of them are smaller than 11. Here's another good chance to pause this video. If you would like to try number 4 on your own, go right ahead and do so now. All right, if I identify the legs first, here is the first leg and the second leg. So my 2 legs in this case are A and 3.6. My hypotenuse is 7.4. That's going to be my longest side. So here we go. A squared plus 3.6 squared has to equal 7.4 squared. So that means a squared is going to be 7.4 squared minus 3.6 squared. Alright, so that means I have to get to my calculator. 7.4 squared. So 7.4 squared minus 3.6 squared is 41.8. That's 41.8. That's a squared. So that means a is the square root of 41.8, which is going to be the approximate decimal. Get back to the calculator one more time. The square root of 41.8, I think that's right in there, is about 6.5. So A is about 6.5. So taking a look at the Pythagorean theorem, make sure that you're plugging in the proper positions A, B, and C, always making sure you identify that hypotenuse to be C. That's it for 4.1. Thanks, guys.